In today's question, we have to find the amount of NaOH in 50 ml of NaOH solution. Clear? Okay, what is data is given? Data is given that there is oxalic acid and NaOH and there is a neutralization reaction. The concentration of oxalic acid is given 0.5 molar and amount is 50 ml. And for NaOH, the amount is given 25 ml. When it is said that when that much amount of oxalic acid is added to the NaOH solution, there is a neutralization. Okay, and what is neutralization? Neutralization is a reaction where there is a acid react with base to form a salt and water. Now you know that the reaction happens in between reactant and there is a formation of the product and consumption of the reactant. So whatever the reaction is happening, it is happening in terms of equivalent weight. That is, if an equivalent weight of NaOH is consumed, then an equivalent weight of oxalic acid will be formed, or an equivalent weight of salt and water will be formed. So we can say that in terms of equivalent weight, what are the equivalent weight of NaOH? The same equivalent weight of the oxalic acid. That is, number of equivalent weight of NaOH is equal to number of equivalent weight of acetic acid. So you can write here number of equivalent weight of oxalic acid is equal to number of equivalent weight of NaOH. You can write this as N1 is equal to N2. What is N1 and N2? N1 and N2 is nothing but the number of equivalent weight of N1 is oxalic acid and N2 is NaOH solution. Now, what is N1 and N2? It is nothing but the N1 V1 is equal to N2 V2. Clear? N1 V1 and N2 V2. N2 V2. What is N1? N1 is the normality of the solution. How to define normality? That is number of equivalent parts of that chemical in 1 liter of the solution. So number of equivalent weight divided by volume of solution. So volume will get cancelled. Whatever remains here, it is called number of equivalent weights. So it will ultimately come N1 and N2. Now data is given in terms of molarity. Okay. But in this equation we have N1 and N2. Now you need to know the relation between molarity and normality. Molarity and normality is nothing but here M1 and F1 V1 is equal to M2 and F2 V2, where M1 is a molarity of the solution, oxalic solution, and M2 is a molarity of NaOH solution. What is NF and NF2? NF1 N factor of oxalic acid, NF2 N factor of NaOH solution. Now how to find N factor? N factor here nothing but the valency of that compound. Okay, this is one definition of N factor. Another way we can say that total number of charge on the either cation or anion, because charge should be same on the cation and anion because that is a neutral compound. So whatever the charge on anion or total number of charge on the cation, that will be our NF factor. And another is for oxalic acid, there is a number of replaceable H positive ions, that is also NF. And in case of NF2 for NaOH, number of replaceable OH negative ions. So you have to remember this. What is the formula of oxalic acid? That is COOH. Okay, now you see there is this H is replaceable, this H is replaceable. So it will become COO2 negative. Okay, COO2 negative. Total number of charge on the ion is -2. And in the case of NaOH, you see NaOH. So number of replaceable is only OH negative, that is only 1. So N factor for oxalic acid will be 2 and N factor for NaOH is equal to 1. Now put the values. Clear? So what is M1 for oxalic acid? That is 0.5 molar. N factor is equal to 2 because 2 replaceable H positive ion, into V1. What is V1? 50 ml. Is equal to M2 molarity. Molarity is not given. We have to calculate the molarity. We have to write as it is. M2 and F2 means N factor is equal to 1 and volume is given, that is 25 ml. Okay, now we can calculate M2. M2 is equal to 0.5 into 2 into 50 divided by 25. It will become 2 into 2, 4. So 4 into 0.5. It will become 0.5 is nothing but 1 by 2. So 1 by 2, here 4. So it will become 2 molar. Okay. So the molarity of NaOH we have calculated, that is a 2 molar. Okay. Now one problem is solved, but we have to find the amount of the NaOH in 50 ml of solution. Okay. We got the molarity of the solution of 50 ml solution. Now we can easily calculate the amount of in that 50 ml of solution. Now here we have to go. Now we have molarity is 2 molar. Now molarity becomes 2 molar. What is definition of 2 molar or molarity? Number of moles of the solute in 1 liter amount of the solution. See, 2 moles means 2 molar means 2 moles of NaOH in 1 liter of solution. Okay, that means 2 moles in 1000 ml of solution. Now, how much solution we have? We have 50 ml solution. 50 ml solution. Then we have to calculate number of moles of NaOH. So X is equal to cross multiply 2 into 50 divided by 1000. Okay, 2 into 50 is nothing but 100 divided by 1000. Okay, is equal to 1 by 10, that is 0.1. So X is equal to 0.1 moles. Clear? We already got the amount of NaOH in 50 ml of solution, that is the 0.1 mole. But now we have to find that in grams. So we can easily calculate what is molar mass of NaOH. That is 40. Okay, that is 40 gram per mole. That means 1 mole is equal to 40 gram. So 0.5 moles is equal to how much? Is equal to how much? So we can easily calculate 40 into 0.1 divided by 1 is equal to 4 gram. So this is a 4 gram. So amount of NaOH in 50 ml of solution is 4 gram. So this is a solution of the problem.